Okay, you can turn off your camera now. Okay, so in the last turn, we have started the discussion about the raster data. In the raster data, if you remember, we have learned about different methods of compression. One was run length encoding. After that, it was block encoding. The next one was chain encoding. Okay. So we have covered till 3 compression methods. And why we were studying these things? Because the size of the raster data is very large. The size of the raster data is very large, therefore it is necessary to compress the data. We have learned 3 of the methods. Now we are moving towards the 4th and the last one, which is a quad tree structure. Okay. First, I am explaining this quad tree structure, and thereafter we will discuss its properties. You know what will happen in the quad tree structure? As the name suggests, it is saying quad. Okay, so quad means quarter over here, 1/4. In quad tree structure, the whole raster area is recursively divided into 4 parts until all the cells of the quadrant have the same value. If any of the quadrant doesn't have the same value, then it will again divide it into 4 parts. So this is how the quad tree structure is created. Basically, it makes the cells of different size. If you see the very first one, this one is the raster data, and there is a combination of white and blue color over here. Okay, white and blue color over here. Now, it means that all the cells of the raster, this 8x8 raster, doesn't have the same value. Therefore, what is done? The raster of 8x8 is divided into 4 quadrants. It means each of the quadrant will have 4x4 cells. So see this quad tree, the second figure, 0, 1, 2, 3. Now this very first quadrant, this 0 quadrant is having same values. There is no problem in this one. For the 1, all the values are again same. For the 2, all the values are remain same, and in the third, there is a combination of blue and white color. I think so. I have taught this quad tree in your class. Have
Yes,
I?
ma'am. Was that,
Yeah.
ma'am?
Yes.
Yes, ma'am.
This topic has been covered. Okay. Have we done the example?
Yes, ma'am, we had given.
Yes, ma'am.
Both from quad tree, from raster to quad tree, and reverse from quad tree to raster?
Not
Raster to quad.
Okay. So when I was teaching, I was feeling that I have already covered this topic. So yes, this particular example has been done, and after that there was a quiz. Yeah. So I think so there is no problem in this conversion. And there is one thing that you all need to remember, the order. Okay, so you have navigated in this example in a Z order. 0, 1, 2, 3. Another option is 0, 1, 3, 2. Okay, so you have already done this example. Now I'm moving to the second one. In this particular example, there is a quad tree. Okay, and what you need to do, you need to convert this quad tree into raster. Okay, and in this case, instead of moving in Z order, you need to move in a pi order, 0, 1, 3, 2 order. Try to generate the raster data from this quad tree. How you will do this one? The things are clearly mentioned. There is an 8 cross 8 at this level, 4 cross 4, 2 cross 2, 1 cross 1. Okay. So if any one of you have any problem in making the raster from this quad tree, you can ask.
Ma'am, you said that we have to use the pi method,
Yeah.
but numbering is given that 1, 2, 3, 4, that we don't have to consider.
No, no.
Okay.
This one is the final answer. See whether you are able to draw the raster data correctly or not. First, there is an 8 cross 8 written over here. So the first step will be you need to create a raster that has 8 rows and 8 columns. Once you have done this one, the second part is 4 cross 4. Therefore, you will divide this area into 4 parts like this in a 4 cross 4 cell. Now coming to the first part, it is showing white color. So it will contain all the white color and there is no leaf coming out from it. It means all will have a white color. But when you go to the second one, you can see that there is a further division in the second one. It means all the cells will not have the same value. So what you will do, you will go to the next level. For the first one, there is no color, no leaf, so all will be white. Second, again, no leaves, all white. Now, coming to the third part, again it has a leaves. So see, the first cell will be in black color and the rest of the cell will be in white color. How we will know? From this last 1 pixel, black, white, white, white. So this is how the next quadrant is filled. And finally, for the last one, there is a black. So all cells will be in a black color. Similarly, when you move to the next quadrant, this one, you again have to see whether there is a leaf or not, and according to that you have to fill the raster. The final quadrant, all there is no leaf over here, so all the cells will be in a black color. So if there is a yes,
मैम इसमें जेड ऑर्डर में मूव करेंगे या पाई ऑर्डर में?
इसमें पाई ऑर्डर में मूव करने को आपको बोला गया था, तो आप इसका रिजल्ट देखिए, पाई ऑर्डर में ही बना है। जेड ऑर्डर में बना होता देन इट विल बी 0 2, जो यहाँ पर फोर्थ है वो पहले आता, और फिर ये जो थर्ड है वो आखिरी में जाता है इस सीक्वेंस में।
मैम एक बार और एक्सप्लेन कर दीजिए।
क्या चीज इसमें नहीं समझ में आ रही वो हमको पूछे तो हम
मैम
बताएं।
वो जो फर्स्ट वाला है वहाँ से मैम, जैसे पहला तो जो 4/4 का है वो 0 है, फिर जो मैम उसके बाद 1 वाला है, तो मैम वहाँ से थोड़ा सा दिक्कत हो रहा है।
देखिए शुरू से देखिए, ये देखिए सबसे पहले क्वेश्चन आता है, आपको बोला गया रास्टर ड्रॉ करिए, लेकिन रास्टर में आप पूछेंगे कि मैं कितने रो में कितने कॉलम बनाऊं, ये पूछेंगे। ये हमको कहाँ से इंफॉर्मेशन मिल रही है? ये देखिए, ये 8x8 जब इसने पहली लाइन में बोल दिया, यहाँ 8x8 बोल दिया, इससे हमें समझ में आ गया कि हमको रास्टर कितने साइज का बनाना है, 8 रोज एंड 8 कॉलम्स का बनाना है। पहला बात ही डन हो गया। अब जब आपने 8x8 का बना लिया, उसके बाद आप देखते हैं कि ये जो है इससे 4 लीफ निकल रही हैं, इसके इस रूट के 4 चाइल्ड यहाँ पर आपको दिख रहे हैं। ठीक है, तो यहाँ पर 1 2 3 4 ये 4 चाइल्ड है, तो आप सबसे पहले तो इनको पूरे रास्टर को 8x8 को 4 पार्ट में डिवाइड करेंगे। अब पहले चाइल्ड पर आइए, चाइल्ड 1 पर। इस पर्टिकुलर चाइल्ड का कोई फर्दर चाइल्ड नहीं है, ये लीफ नोड है, मतलब ये पहला वाला नोड फर्दर डिवाइड नहीं हो रहा है। सिंपल शब्दों में बोले तो इसके आगे कोई भी ब्रांचिंग आपको होते हुए नहीं दिख रही है। इसका मतलब क्या आप निकालेंगे? इसका मतलब आप ये निकालेंगे कि इस नंबर पर, जो नंबर 1 यहाँ पर दिया हुआ है, यहाँ से यहाँ पर जितनी भी सेल हैं उन सब का कलर एक है। कैसे हम इस चीज को बता रहे हैं? क्योंकि यहाँ पर कोई फर्दर ब्रांच नहीं निकल रही है, तो इसका मतलब है कि यहाँ पर और कोई दूसरा कलर आना नहीं है। यहाँ पर व्हाइट कलर दिया हुआ है तो आपने पूरे को व्हाइट फिल कर दिया। कुछ भी यहाँ पर हो सकता है, जैसे यहाँ पर कलर कोडेड दिखाया जा रहा है, इसमें कोई सपोज एग्जाम में आपको क्वेश्चन में नंबरिंग दे दी जाए अगर कलर कोडिंग नहीं क्लियर हो, ठीक है, तो ऐसा कुछ भी यहाँ पर 0 हो गया, सपोज व्हाइट की जगह यहाँ पर बॉक्स के अंदर 0 लिखा होता, तो आप सारी सेल में 0 वैल्यू फिल कर देते हैं। अब अगले पर आइए, नंबर 2 पर आइए। अगला सेकंड क्वाड्रेंट पर आपका आ गया। सेकंड क्वाड्रेंट पर अगर आप देखें, ये जो 4x4 का क्वाड्रेंट बन रहा है, इसमें फर्दर ब्रांचिंग होती हुई आपको दिख रही है। तो अब इस 4x4 को आप आगे फिर से एक बार फिर से 2x2 में डिवाइड करेंगे। क्यों डिवाइड कर रहे हैं? क्योंकि यहाँ पर नंबर 2 पर हमको ब्रांचिंग होती हुई दिख रही है। इस कारण से हम इस 4x4 को फिर से 4 क्वाड्रेंट में डिवाइड करेंगे। ठीक है, क्वाड्रेंट मतलब खुद में ही 4 पार्ट होता है, सो 4 पार्ट्स में हमने इसको डिवाइड किया। अब इसका नेक्स्ट लेवल पर देखिए कितना आपको दिख रहा है। जो पहला वाला सेल आपको दिख रहा है उसमें कोई ब्रांचिंग होती भी नहीं दिख रही है। इसका मतलब है कि सारे सेल जो इस क्वाड्रेंट में आएंगे उनका कलर सेम हो जाएगा। अगले वाले को देखिए, फिर कोई ब्रांचिंग नहीं हो रही है, सारे कलर सेम हो जाएंगे। उसके अगले वाले को देखिए, अगेन यहाँ फिर से ब्रांचिंग हो रही है, तो जो 2x2 का क्वाड्रेंट बना है उसको फिर से आप 4 पार्ट में डिवाइड करेंगे। तो 2x2 को अगर 4 पार्ट में डिवाइड करेंगे तो ऑटोमेटिकली 1x1 मतलब पिक्सल लेवल पर आप आ गए। यहाँ पर पिक्सल लेवल पर अब आप इसका कलर देखिए, पहला वाला ब्लैक है, बाकी सब व्हाइट है, तो आपने पहला ब्लैक यहाँ पर डाला और बाकी सब व्हाइट किया। आखिरी वाले पे देखिए, अगेन कोई ब्रांचिंग नहीं हो रही, सारा ब्लैक है, तो ये पूरा का पूरा ब्लैक कर दिया। सेम चीज 3 एंड 4 के लिए भी है। अब समझ में आ गया क्या हो रहा है?
यस मैम, क्लियर है।
इसको एक बार देख लीजिए और कोई डाउट हो तो पूछ लीजिए। Now we will move to the next part, which is the vector data modeling. We have covered till now about the raster data modeling, and now we are going to cover the second data model, vector data model. So as we have discussed earlier, the real world features are, first of all, we need to select a conceptual model, and after that we have to select the physical model. So what was the conceptual model? Raster and vector are two conceptual models through which you can represent the spatial data. So we have covered the raster part, and now we are moving towards the vector part. Okay. Now, everyone in your copy, try to explain the vector by yourself. Okay. Try to explain. If somebody asks you what is vector data, okay, I'm not going to ask from any of the student. Now it's at your end, you have to see how much things you have remembered till now. We have already seen the vector data in the practical sessions. We have learned how to generate the vector data and other things. In the theory session also, we have covered a lot about the vector data. Again, there is a topic of vector data modeling, and in this one, we will learn about the data structures also, spaghetti data model, topological data model over here. But before going into that detail, just try to recall how many things you remember about the vector data model. So what you need to do, you need to write it down in your copy, what is vector data model. Just 1 minute time, write down what is vector data model. Okay then. So I hope you people are able to write something about the vector data model. Now, what is vector data model? Vector data model, which is also known as discrete object model. It uses discrete objects to represent the spatial features on the Earth's surface. So vector data model uses the geometric objects of point, line, polygon to represent the spatial feature. So when anything has a 0 dimension, a point will be used. So a point has a 0 dimension and has only the property of a location. So a point feature is made of a set of point or a coordinate, and you can use well some lamppost, some religious place to show with the help of a point. Okay. Next thing is line. What is the dimension of line? Line is a single dimension or one dimensional and has the property of length in addition to location. In case of point, we will just have a location. There will be no length, there will be no area. But in case of line, it will have, yes?
Ma'am, point slide 1 is coming, ma'am. I think there is lag between video and audio.
Okay.
Ma'am, now it has come. Line slide.
So when we talk about a line, line is a one-dimensional object. With the point, it is just a location without any dimension. In case of line, we will have coordinates. We have an ordered set of points or coordinates, and with the help of that, we can represent a length. So that's why a line is a one-dimensional object which has a property of length. Now, when we talk about a line, how many points can be there? Minimum 2. Okay. In means if we as a non-GIS person, when we talk about a line, as a mathematician, if you say line, it will means straight line. There will be one start coordinate, there will be one end coordinate. That's it. Okay. The term polyline is the correct one. Polyline means that there will be a collection of points. There will be an ordered set of points in case of polyline, where the first and the second point will be connected by a straight line. Second and third point will be connected by a straight line, and so on. Okay, so each point is connected to the next consecutive point by a straight line. This is how a polyline is generated. Here also, when you have done the digitization, the same thing has been happened. Okay, you must have noticed this thing. As you mark the vertices on the road, automatically the previous point is connected with the next point by a straight line. So this is how the whole line is generated. So a point can have, a line can have just 2 points, or it can have several points. There will be one start point, there will be one end point. So the shape of a line may be a connection of line segments, or it can be a smooth curve, which is defined by a mathematical function. In the literature, you will find different terms for the line, like edges, like arcs. Okay, in ArcGIS software, the arc means line. Okay, so if you go to the means older literature, in the older literature, instead of line, they use this term arc and edges and other things. But nowadays, we do not use arc, edges, polyline, nothing like that. We simply use the term line. Okay, so if you find anywhere that edge, arc, polyline, everything is line. Okay, so don't get confused if you are reading books. So when we talk about a line, it will refer as a line or as an arc. It will have an ordered set of pair with a different start point and the end point. Okay. Whether there is a line, whether there is a point, attribute will be attached. With a point, attribute will be attached to a single location, to a single point. With a line, the attribute will be attached to the whole line, to all the vertices of that line. Next one is polygon. So there can be a polygon, it can be area. Both the terms are correct. In different books, you will find different terminology, but both are okay. Okay. So if you are talking about area or if you are talking about the polygon, how we will define that one? It is a two-dimensional entity that has the property of area and perimeter in addition to location. Okay, so are you getting this thing? Point, just only location. Line, location and length. Polygon, location, area, perimeter. So write it down this thing in your copy. Okay, so you just need to note it down so that there will not be any confusion with you. Point will have location and there will be just one x and y. With the line, location and length will be there, and there will be an ordered set of coordinate with a distinct start and end point. With polygon, you will have location, perimeter and area. Again, there will be an ordered set of points where the first and the last point will be same. Although in today's time, the computers are more advanced, the technology is more advanced, and therefore, first, if you check the coordinate set, the first and last are not same. Okay, because it is automatically taken over there that the first and the last coordinate will be same. So you have seen point, you have seen line, you have seen polyline, you have seen polygon. We have already discussed about the attribute. Attribute will be associated with just one location for point with the whole length for the line. And when we talk about the polygon, the attribute will be associated with the whole polygon, with the whole area. Okay. With the polygon, there are few terms like there can be a convex polygon that we have already discussed previously. In case of convex polygon, all the internal angles will be less than 180 degree. Okay. There is a term called minimum bounding box. When we work on the database, this minimum bounding box or minimum bounding rectangle, MBR or MBB, is frequently used. What is the meaning of minimum bounding box? If you listen this term carefully, minimum bounding box, it is explaining itself. Okay? Like suppose that there is a set of points. Okay? There is a set of points, then the polygon of minimum size, minimum area, which is completely covering those points, is called minimum bounding box. Why this is important for us? Because when you perform the query on database, many times instead of doing the query on the actual geometry, because it is complicated thing, it is a time taking, resource taking process to perform a query on the actual shape, what happens, instead of taking the actual geometry, a minimum bounding box is taken around that one, and then with the help of that minimum bounding box, the query is performed. So sometimes there can be there can be error while performing the query through minimum bounding box. How? Can you draw any of the example where the query through minimum bounding box or minimum bounding rectangle can get failed? Hope everybody is getting this concept of minimum bounding box. Minimum bounding box means if you have a set of points or if you have a set of lines and you need to draw a polygon around it with the minimum area, then that polygon is called the minimum bounding rectangle or minimum bounding box. Why it is important? Because in many of the databases, instead of performing the query on the actual geometry of the object, the query is performed on the minimum bounding box that is drawn around the entities. Why this is done? Because when you have to perform the query on the actual geometry, it will take a lot of time. So in order to avoid that one, the minimum bounding box is used. So in some of the software, they do not have the capability to perform the query on actual geometry. Okay, and sometimes in order to save the time, this minimum bounding rectangle, minimum bounding box is used. So there is a very small question. Quickly try to draw a figure in which you can show that the minimum bounding rectangle query could get failed. It will give you some wrong result. Try to read by yourself, then I will show you the example. So this one is the hint for you. I have drawn two lines. And now try to make a special query on these lines using the minimum bounding box, and how this query will get failed or it will give you incorrect result. I hope you people are able to draw the answer. I'm just showing you. So how a minimum bounding rectangle will be drawn over here. For this first line, it will be drawn like this. And now if I draw a polygon for the second one, minimum bounding. Okay. Now, if there is a query, okay, if there is a query whether these two lines intersect with each other or not, what will be the answer? If you perform on the actual geometry, the question is whether these two roads intersect with each other or not. What will be the answer? It will be no, isn't it? Because roads were not intersecting with each other. But when the same query is performed on the minimum bounding box, as you can see on the screen, the first one is a green color box, the second one is a red color box, and you can clearly see the both the boxes are intersecting with each other. It will give you incorrect answer that yes, both the lines are intersecting each other, but in reality they are not intersecting. So I hope you people are able to understand, get the concept of minimum bounding box over here. I am giving you one of the tasks. You need to search by yourself about these terms. Okay. All the terms are related to each other. This one is for the line. There can be a line segment, simple polyline, monotone polyline, okay. So these are the terms which are related to line. Okay. Next, you have to identify some of the terms which are related to polygon.
Ma'am,
यस
मैम अभी जो आपने बताया मिनिमम बाउंडिंग बॉक्स रेक्टेंगल, मैम इसका बेनिफिट क्या है मैम? क्योंकि मैम हमारे पास तो पॉलीगन का कॉन्सेप्ट है ही है, और मैम इसमें ओवरलैप भी हो रहा है, इंटरसेक्ट भी हो रहा है। मैम इसको आखिर लिया क्यों गया?
ये ऐसा हमेशा नहीं होता, ये कभी कभी एक्सेप्शनल केसेस होते हैं जहां पर ऐसा किया जाता है। यूजुअली अगर आप एक्चुअल ज्योमेट्री पर वर्क करते हैं तो ये बहुत टाइम लेता है, इसलिए कभी कभी क्वेरिंग में हम मिनिमम बाउंडिंग बॉक्स को यूज करते हैं। हमेशा नहीं होगा कि इस तरीके की एक्सेप्शनल सिचुएशन है, तो कई बार आ जाती है। बाकी ये ज़रूरी नहीं है कि क्वेरी के लिए यूज हो। मिनिमम बाउंडिंग बॉक्स आप आगे चल करके जब वेब जीआईएस में पढ़ेंगे तो कोई भी आप फीचर लेते हैं, जब आप उसको अपलोड करते हैं तो आपको उसका एक्सटेंड देना पड़ता है कि वो कहाँ से कहाँ तक लाई कर रहा है, उसका टॉप लेफ्ट एंड बॉटम राइट कॉर्नर जिसमें कि वो पूरा का पूरा स्पेस लाई करता है। उसके लिए हमें उसका बाउंडिंग बॉक्स बार बार देना पड़ता है। इसको चलिए जल्दी से एक एग्जांपल यूज करते हुए हम आपको दिखा देते हैं। तो आप सभी लोगों को यहाँ जो एग्जांपल्स दिए गए हैं, ठीक है, यहाँ पर ये अलग अलग कैटेगरीज यहाँ पर लाइन की दी गई हैं। लाइन सेगमेंट, पॉलीलाइन, नॉन सिंपल पॉलीलाइन, मोनोटोन पॉलीलाइन, नॉन मोनोटोन पॉलीलाइन। इसी तरीके से पॉलीगन के लिए सिंपल पॉलीगन, नॉन सिंपल पॉलीगन, कॉन्वेक्स पॉलीगन, मोनोटोन पॉलीगन, पॉलीगन विद होल। आपका काम क्या है, इन सभी का मतलब, ठीक है, अगर आपको कोई बोला जाए दैट दिस वन इज अ मोनोटोन पॉलीगन, देन व्हाट इज द मीनिंग ऑफ मोनोटोन पॉलीगन। इसी तरीके से मोनोटोन पॉलीलाइन ये क्या होता है, इसके बारे में जाकर के नेट पर सर्च करिएगा, प्लस इनके फिगर्स बनाइएगा कि लाइन सेगमेंट का फिगर कैसे होगा, पॉलीलाइन का कैसे होगा, मोनोटोन पॉलीलाइन का फिगर कैसे बनेगा। तो ये आपके एंड पर काम है कि आप इन सब के बारे में देखें और सर्च करें कि ये कैसे करता है। ठीक है, यहाँ एक क्वेश्चन अभी मिनिमम बाउंडिंग बॉक्स के लिए पूछा गया, उसका एक एग्जांपल आपको दिखा रहे हैं। उसमें थोड़ा सा कंफ्यूजन इसलिए आ गया क्योंकि एक्सेप्शन पहले समझा दिया गया। इसका एक यूज दिखा देते हैं पॉजिटिव उसमें। यहाँ पर एक एग्जांपल दिखाने, ये इलाहाबाद वार्ड बाउंड्री का डेटा है मेरे पास, और इस डेटा को हमने अपने सर्वर पर, जब आप वेब जीआईएस सीखेंगे तो ये सारी बातें जानेंगे आगे चल करके, कि यहाँ पर हमने अपना डेटा सेट सर्वर पर अपलोड किया। जब भी आप सर्वर पर अपलोड करेंगे, देखिए यहाँ पर इसका बाउंडिंग बॉक्स दिया गया है। देख रहे हैं इसको, यहाँ पर इसका बाउंडिंग बॉक्स दिया गया है, और ये देखिए मिनिमम एक्स, मिनिमम वाई, मैक्सिमम एक्स, मैक्सिमम वाई, देन लैटिट्यूड लॉन्गिट्यूड बाउंडिंग बॉक्स इसी का, क्योंकि ये दोनों ही जीसीएस ज्योग्राफिक कोऑर्डिनेट सिस्टम में है, इस कारण से इसका सेम आ रहा है। मिनिमम एक्स, मिनिमम वाई, मैक्सिमम एक्स, मैक्सिमम वाई। ठीक है, अब हम जब इसको ड्रॉ करते हैं, इस लेयर को हम प्रीव्यू करके दिखाते हैं। जब इसके ऊपर क्लिक हो रहा है तो ये वार्ड बाउंड्री मेरा जो पूरा है डेटा ये सामने आ जा रहा है, और इसका देखिए ये एक्सटेंड जो है ये इसका यहाँ से निकल करके आ रहा है कि ये कहाँ से, ये देख रहे हैं इसका जो बॉक्स, ये किस एक्सटेंट तक ये पूरा का पूरा डेटा सेट रहेगा, ये कैसे मिल रहा है। ये अगेन मिनिमम बाउंडिंग बॉक्स, यहाँ पर इस सॉफ्टवेयर में जियो सर्वर में इसको बाउंडिंग बॉक्स टर्म यूज किया गया है, तो उसी के अकॉर्डिंग इसको पूरा बनाया जा रहा है। टोपोलॉजी इसको बाद में कवर करेंगे। पहले वेक्टर डेटा स्ट्रक्चर में स्पेगेटी मॉडल पढ़ते हैं एंड देन टोपोलॉजिकल डेटा मॉडल जब पढ़ेंगे तब वहां पर टोपोलॉजी के बारे में जानेंगे। सो फर्स्ट वन इज स्पेगेटी मॉडल। So vector data that have been collected but not structured are said to be in a spaghetti data model. It is the simplest vector data model that stores the data without establishing relationship among the geographic features. Each point, line or polygon is stored as a record in a file that consists of that entity's ID and a list of coordinates that define geometry. So what is a spaghetti data model? It is a very simple vector data model. In this data model, there will be 3 files, one for point, one for line, and the last one for polygon. In each of the file, there will be 2 columns. First one is for the ID, second one is for the coordinates. For the point, you can see that there are just 2 points, point 1 and point 2, and the corresponding coordinates are written 3, 4, 5, 5. For the line, again there are just 2 lines, line 1 and 2, and the coordinates are given over there. 0, 1, 3, 4, 5, 6. Then for the second, 3, 1, 5, 2, 4, 3. Okay. Then for the third one, which is polygon, again just the ID and the coordinates are given, and see the thing that the first and the last coordinate are same. For ID1 it is 2, 4, 4, 3, 3, 6, and again 2, 4. For the second one, it is 3, 1, 5, 2, 4, 3, 3, 2, and again 3, 1. So this is how the spaghetti data model stores the vector data. It will take the ID, it will store the coordinate. So this is a very simple data model, and it is a very good data model if you just want to retrieve the data and use it for the visualization purpose, because on the basis of query, the entities will be selected and they will get displayed. But the problem with this model is that it does not store any information about the adjacent things, about the neighborhood. Okay, like 1 does not know whether 2 is in its right side or in its left side. Okay, if you see this line, 2 lies on the right hand side of 1, but in the data model this is not stored. So how this is a problem? If you want to perform advanced analysis, suppose if I want to perform, say, road shortest path analysis on this line data, it will not be possible. Why? Because roads are connected to each other. Only then you can find the shortest path, and connectivity information is completely missing in this one. Nobody knows whether the line 1 is connected to the line 2 or not. So you cannot perform the shortest path analysis on such type of data. Similarly, which polygon is neighborhood in another polygon, this information is completely missing. Any type of advanced data analysis could not be performed on a spaghetti data model, or it will take a lot of time. It will take a lot of time to get the spaghetti data, to perform the analysis on a spaghetti data model. Okay. So in the examination, if there is a question that a data set is given to you, or some point, line and polygon is given to you, and question is, give the spaghetti data model of this data set, what you will do? You will create just 3 tables. Table 1 for point, table 2 for line, and table 3 for polygon. And in that one, you will draw 2 columns, first one for the ID, second one for the coordinate. That's it. So in the examination, if you need to do, if there is a question on spaghetti data modeling, you will draw three table, and in each of the table there will be ID and the corresponding coordinates. Now, if we see the name is very special, spaghetti. What is a spaghetti? Now you can think spaghetti something like noodles. Okay? So everybody must have eaten Maggi or chow mein or something like that. Now suppose if you take a bowl of noodles and anyhow that bowl falls from your hand and spaghetti or the noodles get spread on the floor. And what you will do, you will try to put that back inside the bowl. Will you retrieve the original setup? The answer is no, because you do not know which noodles strand is overlapping the other one, which is creating a loop and other things. Similarly, in this data also, you cannot find such type of relationship among the point, among the polygons. Therefore, this particular name is given spaghetti data model for such type of data structure. So, what are the positive or what are the advantages? It is very easy to create. It is very easy to retrieve the data. It is very easy to render the data on the screen. Problem, you cannot perform any sort of operation, any type of advanced analysis that involves the information of neighborhood. Okay. So whether it is a shortest path analysis, whether it is any type of proximity analysis, it is very difficult to perform that thing on a spaghetti data model. You could perform that one, but it will take a lot of time to compute these things. Next data model is a topological data model. And before coming to that topological data model, I will first cover topology, which we have already seen in the starting classes, 1 or 2 classes. In this session, we will see in detail what is topology. So it's 11:50. I'm giving you 10 minutes break. At 12 o'clock, we will start from the topological data model. So let's start the class again. So we have left on the topic of topology. Okay. What is topology? Okay. So topology refers to the study of those properties of geometric objects that remain unchanged under certain transformation, like if there is a bending, if there is a stretching, then those properties will not get changed. Okay. Like suppose there is a rubber band, and if you try to stretch it, if you try to bend it, it will remain a closed circuit. So this is called the topological property of that rubber band. Another example could be like suppose there is a map of subway stations. Okay. Or there is a cartogram. The correct term is cartogram. You will later on learn what is cartogram and how it is different from the map. But for the simplicity purpose, I'm saying it map right now. Suppose you have a metro map or a subway stations map. So that map will correctly depict the connectivity between the subway lines, between the subway stations on each of the line. But it will distort the distance, it will distort the direction in order to make it readable and understandable. In GIS, vector data can be topological or it can be non-topological, depending upon whether the topology is built into the data set or not. Okay. So in a simple words, if we try to say what is topology, all those properties that remain unchanged when there is a stretching, when there is a bending, then all those properties are called the topological property. There are three main things: adjacency, connectivity, and containment. Okay. First term is adjacency. First term is adjacency. Adjacency means which polygon is sharing the boundary of another polygon. Okay. This is called the adjacency information. When two polygons shares a common boundary, then they are known as adjacent polygon. Next is containment. Containment, you can think like there is a island and that island is surrounded by the river. So in that case, river is containing that piece of land, that island. So this is called the containment. The third one is the connectivity. Connectivity means whether there is a linkage between the linear features or not. So between the lines, we maintain connectivity information, which lines are connected with the other ones. So this is the topological properties. Okay. Now search, go to the internet and search which properties are not topological property, or you can try it by yourself. Which property? I have told you three properties as a topological property: adjacency, connectivity, and containment. Sorry?
Cutting.
Cutting?
Means we cannot cut a line or a ring.
Which property will be a non-topological property? Means, in other words, if I say if you stretch something, if you bend something, which properties get deformed? Like if you stretch, suppose if you draw two polygons, one polygon lies inside the another polygon, and even after that, if you try to stretch that one, okay, like yes, like in this particular example, this one is the Prayagraj ward boundary map. So if I try to stretch the boundary, or if I try to stretch this polygon, whether some of the ward will go out of the Allahabad ward boundary or not? The answer is no, they are not going to run out of the polygon. Okay. So in that case, this containment is called the topological property. But now if I am trying to stretch the rubber sheet, in that case, the area will get changed. The distance will get changed, or the perimeter will get changed. The direction will get changed. In that case, these properties will known as the non-topological property. Okay. So you can see this particular example. I think so there is a little bit screen lag between my audio and video. Just wait for a minute. I am showing a figure. Yes. So this one is the figure which is showing the transformation. As you can see in this figure, the first figure is, you can see that this one is a regular rectangular figure. And when you are stretching or bending this particular area, you can see the size of the A is getting distorted. The area, the distance direction is getting distorted. Similarly for the other one. But if you see D and E is contained inside D. Even after stretching, bending, E is remain inside D. A and B are adjacent to each other, and even after this distortion, they remain adjacent to each other. So this is how we decide whether a property is called a topological property or whether it is a non-topological property. Some of the examples are given over here for the topological operation, like Vancouver is on the boundary of Canada and US, Minneapolis is inside the Minnesota state, Madison is outside the Minnesota state, interior of Canada is an open area, Charlton country is closed region, Switzerland is a connected region whereas Japan is not. A point is within the loop, a road passes through a forest. Minnesota is a neighboring state of Wisconsin. Interstate Freeway 90 passes by Lake Michigan. So these all are the example of topological operation. Okay, like first one is saying about the adjacency, Vancouver's adjacency. Second one is telling you the connective containment information. Third one is also giving you the containment of information. Then there is no connectivity, I think so, in this example. So these all are the different topological operations that you can find over here. After the topological, next are the examples of non-topological operation, which are distance, direction, length, perimeter, and area. Okay. Now coming back to the vector data model, at present, there are two types of vector data model. We can classify it like this, that there can be a topological data model and there can be non-topological data model also. Now, before going into the detail of that one, go to the internet and search the name of some topological vector file format and some non-topological vector file format. Quickly go to the internet and search the name of topological file formats or topological vector formats. So you need to find out the example of topological vector data.
Ma'am,
Yes.
ma'am, can we relate topological to geoid undulation? Same both.
No. So nobody is getting any name on topological data model. Examples of best known examples of topological data models. I'm giving you the first name, DIME. See the full form of DIME? This is the full form of DIME, Dual Independent Map Encoding. This one was created, this model was created by US Census Bureau to automate the storage of street map data for the decadal census. Okay, so very first example is DIME. You need to remember these things. Okay, these all are the theoretical things. You may not be using all this, but you should know the name of these file formats. DIME, Dual Independent Map Encoding. Who has given this one? US Census Bureau. What was the purpose? To store the map data. For what? For the census, decadal census data. Any other name?
Tiger.
Yes. So with the help of the DIME data, they have stored the, not just, it is basically a line format, and they have stored the information of street, river, railway lines, and so on. Another one was Tiger. What is the full form of Tiger?
Ma'am, topologically integrated geographic encoding and referencing.
Yes. All of you note down this one also. Tiger, topologically integrated geographic encoding and referencing. Okay. So some problem of the DIME have been eliminated with the help of this Tiger, which is topologically integrated geographic encoding and referencing system. And it was designed for use in the year 1990 again for US Census Bureau. DIME was also from the US for the US Census Bureau, or it was developed over there. Tiger, you can say that it was developed to eliminate some of the problem or errors that are generated in DIME. So Tiger, again, it was developed by the US Census Bureau, and in this Tiger system, points, line, areas are explicitly addressed, and therefore census blocks can be retrieved directly by block number rather than by relying on the adjacency information contained in the link. So Tiger's file format is very frequently used. I will show you one example of that one. Yes. Okay. So this one is the example of Tiger, which was used by the Tiger. Basically, there is a Tiger database from US Census Bureau, and this Tiger database links the statistical area boundaries of the country, of the counties, of the census tract, of the blocks. Okay, they contains all this information and they link it with the road. They link the block and other information with the road, railway line, river, and other features. Okay. As you can see over here, that they used to store all node, arc, face. Node means point, arc, node means point, arc means line, face means polygon. Okay, so this is a different terminology that was used in this file format. And another example is given over here, that they are showing how the addresses are stored inside this one. Address range and zip code in the Tiger database have the left or right side designation based on the direction of street. Later on, we will learn about the geo coding thing. Okay, over there you will find the application, or then you will understand what is given over here. There is a concept of geocoding. Okay, so we will cover that thing later. So there was Tiger database, and then there is another one, which is, just wait a minute. There is a DLG. Okay, what is DLG? Digital line graph. Digital line graph. So who has given this DLG? It was given by USGS. The previous two are given by the US Census Bureau, but DLG was given by the USGS, United States Geological Survey. So DLG are the representation of point line and area feature from USGS quadrangle maps. Remember this term. Quadrangle maps. This one was produced by the USGS. Okay. So these maps contain all this contour lines, hydrography information, administrative boundaries, transportation. All this information is contained over there. Okay. So this is about the topology. Okay. So what are the advantages of topology? If you see, you have seen some of the vector file format that uses the topological vector data model. But when we talk about the advantages, first one is it ensures the data quality and integrity. So that is why the topology is used everywhere. It will help the GIS, it will help in the GIS analysis. Then it will help you to give the information of direction and other things. So that's why the topological data is very important. Which file format do you create during digitization process? Your digitized data is in which file format? In shapefile format. Okay. So how many extensions are there, and whether the shapefile format is a topological vector data model or not? Fine. Well, first question, whether the vector file format is a topological data model or not?
Yes, ma'am.
Check it again. Check whether the shapefile is a topological data model or not.
Yes, ma'am, it is there.
Where it is written? Okay, let me also search.
No, ma'am. Non-topological.
Okay, I'm not going to search anybody else. जल्दी से ढूंढ के बताइए, यहाँ पे दो आंसर आ रहे हैं, एक बार टोपोलॉजिकल, एक बार नॉन टोपोलॉजिकल. सब लोग जल्दी से अपने नेट पे ढूंढिए कि शेप फाइल फॉर्मेट टोपोलॉजिकल है कि नॉन टोपोलॉजिकल है.
नॉन टोपोलॉजिकल है.
सबका आ रहा है नॉन टोपोलॉजिकल?
यस मैम.
ठीक. तो ये याद रखिए, क्योंकि शेप फाइल आज के टाइम में हम लोग जितना भी सब चीजें यूज कर रहे हैं सब शेप फाइल फॉर्मेट में है. तो ये जानकारी होना बहुत जरूरी है कि शेप फाइल टोपोलॉजिकल है कि नॉन टोपोलॉजिकल है. नेक्स्ट थिंग इज, शेप फाइल में कितनी फाइल्स बनती हैं?
और
No.
SHP, SHX, DDF,
Video is not clear.
टोटल 6 है मैम. तो मैम
यस,
टोटल 6 है मैम।
टोटल 6 हैं। कौन कौन से?
SHP है, PRJ, SHX, DBF, SBN, SBX।
Okay. These are the main files. Okay. First thing is shapefile is a non-topological file format. Means somebody may ask, after learning so many advantages and efficiency of topological data model, why the shapefile, which is rampantly used for the vector data modeling, is a non-topological structure. Okay. So answer is because of the advances in computer processor speed, there is a massive increase in the capacity of storage devices. Therefore, there is a reduce in the need of explicit topology. So shapefile was a reaction of all these computer advancements, and therefore it is a non-topological data model that stores the geometry and attribute information of geographical and spatial features in a data set. So the geometry for each feature is stored in a shape which comprising a set of vector coordinates. Okay, and these are linked to the attribute table. So if you see, there are majorly, although there can be 5, sometimes there can be 6 files when you create a shape file. But if I talk about the first two are the one that store the spatial information. So the SHP will store the
मैम
yes.
मैम आपने जो रीजन बताया वो समझ में नहीं आया मैम कि क्यों हम शेप फाइल में ही करते हैं बीइंग दैट इन नॉन टोपोलॉजिकल डेटा।
टोपोलॉजिकल डेटा के बहुत सारे एडवांटेजेस अभी हम लोगों ने देखे, लेकिन जैसे बताया कि कंप्यूटर का जो प्रोसेसिंग का स्पीड है वो बढ़ गया है, स्टोरेज का स्पीड है वो बढ़ गया, स्टोरेज की कैपेसिटी जो है वो बढ़ गई है। इस कारण से जब आप टोपोलॉजिकल डेटा भी, उसको भी हम लोग आएंगे अभी, टोपोलॉजिकल डेटा मॉडल कैसे बनाया जाता है, उसमें आप देखेंगे कि टोपोलॉजिकल डेटा मॉडल बनाना इटसेल्फ एक कॉम्प्लिकेटेड प्रोसेस है। अगर आप एक्सप्लिसिटली टोपोलॉजिकल इंफॉर्मेशन, टोपोलॉजी की इंफॉर्मेशन स्टोर कर रहे हैं तो ये एक टफ टास्क हो जाता है। अब क्योंकि स्टोरेज की या आपको जो प्रोसेसिंग की स्पीड, अब पहले के टाइम की तुलना में ये जो सारा ये डेवलपमेंट आपको बताया गया, डाइम है, टाइगर है, टाइगर 1990 में आया, डाइम उससे भी पहले आया, तो ये बहुत पुराने फाइल फॉर्मेट्स हैं और उस समय का कैपेसिटी अगर कंप्यूटर की देखें, पावरफुल देखें तो वो बहुत कम होते थे। आज के टाइम एक कॉमन मैन भी, हम और आप भी एक बहुत ही हाई कैलिब्रेशन का सिस्टम यूज कर रहे हैं। इस कारण से जो प्रोसेसिंग का इशू जो पहले आ जाता था टोपोलॉजिकल डेटा मॉडल को सेव करने में, नॉन टोपोलॉजिकल को सेव करने में, वो अब उसी के कारण से, क्योंकि कंप्यूटर इतना एडवांस हो गया कि अगर आपको जरूरत है तो वो कंप्यूट कर देता है। ठीक है, एडजेसेंसी ऐसा नहीं कि नहीं निकाली जा सकती, वो उसको पूरा कंप्यूट करके निकालना पड़ेगा। इस कारण से शेप फाइल फॉर्मेट आया। शेप फाइल एक इसरी का फाइल फॉर्मेट है, लेकिन ये नॉन प्रोप्राइटरी फाइल फॉर्मेट है, नॉन लाइसेंस, नॉन प्रोप्राइटरी। इसी कारण से आप देखेंगे ऑल्दो ये इसरी का, ये ArcGIS का प्रोडक्ट है, लेकिन फिर भी आप इसको किसी भी सॉफ्टवेयर में, अगर आप सपोज QGIS पे काम कर रहे हैं उसमें भी खोल सकते हैं, एडास पे काम कर रहे हैं एडास में भी खुल जाएगा, इल्वेस में भी खुल जाएगा, एनवी पे भी खुल जाएगा, किसी भी सिस्टम, किसी भी सॉफ्टवेयर में आप काम करते हैं उन सब में ये शेप फाइल खुलती है। तो ये एक नॉन प्रोप्राइटरी फाइल फॉर्मेट है, इस कारण से ये बहुत ज़्यादा यूज हो रहा है। बाकी टोपोलॉजिकल में क्यों नहीं यूज होता ये आपको हमने बता दिया। सो यहाँ पर जब शेप फाइल बनेगी, 4 फाइल बनेगी। पहली SHP बनती है जो कि शेप की ज्योमेट्री यूज स्टोर करता है। SHX किसके लिए होता है? पोजीशन नहीं, इंडेक्सिंग, स्पेशल इंडेक्सिंग। ये डेटाबेस का कॉन्सेप्ट है इंडेक्सिंग, लेकिन स्पेशल इंडेक्सिंग का स्टोरेज .shx करता है। PRJ क्या करता है? प्रोजेक्शन इंफॉर्मेशन को स्टोर करता है। लास्ट वन इज DBF, ये किस लिए होता है? डेटाबेस का क्या मतलब है?
डेटाबेस फॉर्मेट।
डेटाबेस का मतलब क्या है?
एट्रीब्यूट डेटा।
यस, एट्रीब्यूट। तो DBF स्टैंड्स फॉर डेटाबेस डीबेस बेसिकली, ठीक है। जो .dbf होता है वो डीबेस के लिए होता है। मेन फाइल .shp होती है, ये आप डायरेक्ट एक्सेस होता है इसमें लिस्ट ऑफ वर्टिसेस, जो भी उस शेप को बनाने के लिए जो जितने भी पॉइंट्स आप मार्क करते हैं उसकी पूरी लिस्ट .dbf में स्टोर होती है। दूसरा .shx जो कि इंडेक्स फाइल होती है, इसमें इंडेक्सिंग जो करी जाती है डेटाबेस में उसके लिए इसको यूज किया जाता है। DBF जो उसका एट्रीब्यूट होता है, यानी कि डीबेस टेबल जो होती है वो बनाया जाता है इसमें। इस डीबेस टेबल में पूरी की पूरी एट्रीब्यूट इंफॉर्मेशन स्टोर होती है, ठीक है। बाकी मेन हम लोग जब बात करते हैं ये तीन मेन होती हैं, ठीक है, SHP, SHX, DBF। इसके सिवा आप बहुत सारे दूसरे इसमें कई बार बन जाते हैं, वो तो रहते ही हैं, बट 3 थिंग्स इसमें मेन है, SHP, SHX, DBF। इसीलिए बोला जाता है कि जब भी आप शेप फाइल कॉपी करें तो वो कंप्लीट सेट कॉपी करें। ऐसा नहीं हो, क्योंकि ये मिस्टेक हो जाती है कि शेप फाइल तो SHP है तो हम केवल SHP कॉपी कर लें तो काम हो जाएगा। आप देखेंगे कि अगर आप केवल SHP कॉपी करेंगे तो वो आपका जो भी डेटा है वो ओपन ही नहीं होगा। आपको पूरा का पूरा ये सेट कॉपी करना पड़ेगा, तब आपकी शेप फाइल जो है वो कॉपी होती है, ठीक है। तो ये शेप फाइल के बारे में हो गया। शेप फाइल मींस ऐसी फाइल जिसमें कि नॉन टोपोलॉजिकल फॉर्मेट होता है, ठीक है। बाकी पास्ट में जैसे ArcGIS का भी अगर हम लोग पुराना देखें, शेप फाइल तो बाद में आया, पहले कवरेज फाइल्स बनती थी। ये पुराना है जो आज हम लोग यूज नहीं करते, बट पास्ट में, क्योंकि इसको भी बने बहुत टाइम हो गया, तो पास्ट में कवरेजेस बनते थे, उसमें ये कवरेज में टोपोलॉजिकल इंफॉर्मेशन स्टोर होती थी। बट जब हम लोग शेप फाइल की बात करते हैं तो शेप फाइल में नॉन टोपोलॉजिकल डेटा यूज स्टोर किया जाता है, ठीक है। चलिए अब नेक्स्ट टॉपिक पे आए वापस से। तो हम लोग ने एक डेटा स्ट्रक्चर सीख लिया जो कि था स्पेगेटी डेटा मॉडल, ठीक है। नेक्स्ट सेकंड हम सीखने जा रहे हैं टोपोलॉजी का पूरा डिस्कशन कर दिया, उसके एग्जांपल्स आपको बता दिए, उसके फॉर्मेट्स बता दिए हैं। अब नेक्स्ट हम लोग जा रहे हैं जो टोपोलॉजिकल डेटा मॉडल है वो स्टोर कैसे होता है इसमें डेटा, ठीक है। तो उसको पहले रीड करते हैं और फिर एग्जाम्पल की हेल्प से आपको एक्सप्लेन करेंगे। सो मोर sophisticated topological data models store relationships among different features in a database. For example, lines that cross will be split and an additional node will be added at the intersection. Instead of defining the boundary between neighboring polygon twice, once for each closed loop polygon, the line is stored only once, together with information on which polygons are stored to the right and left of the line respectively. Information about the relationship between nodes and lines and polygons are stored in attribute tables. The objects of interest in this model are the following: point, node, arc, polygon, region. Advantage of this model: efficient computation of topological queries. Consistency, maintenance, and updates are easier. Drawback: the complexity of resulting structure may slow down some of the operation. First of all, I will explain the whole thing with the help of an example. So before going into the detail, you first need to draw this diagram. I have drawn a feature over here. So there are two nodes N1 and N2. There are 4 arcs A1, A2, A3, A4. There are 3 polygons A, B, and C. Okay. How we are going to store this data? Let's see. In spaghetti, we just need to create 3 tables, one for line, one for point, and one for polygon. In case of topological data model, we need to create 4 tables: arc coordinate data, arc topology, node topology, polygon topology. Okay, so we will start one by one. Arc coordinate data. First of all, you need to create this table. In this table, there will be 4 columns: arc, starting XY, intermediate XY, and ending xy. Means you need to give the name of the arc A1, like for the A1. What will be the start? If you see this graph, this one is the undirected graph. So N1 or N2, anyone can be the node for the, can be taken as the starting node. So suppose if I take N1, okay, this, I suppose if I say it is starting from N1. So starting xy will be 4, 5. Okay. Intermediate will be 8, 4. Sorry, 4, 8, 8, 8, 8, 1, 4, 1, and xy will be 3, 4. 4, 3. Okay. So this is how this arc coordinate data will be created. 4, 3, intermediate nodes will be like this and end will be this. So what now you need to do? You need to create the remaining rows for A2, A3 and A4. The thing is simple. You have to select the starting xy from the node. All the arc will start from a node and end to a node. So there is A1, A2, A3, A4. There are total 4 arcs over here. You have to give the start xy, intermediate xy and end xy. Okay. So first of all, draw this arc coordinate data. First entry is given for the arc A1. For rest of the 3 arcs A2, A3, A4, you need to write down the detail by yourself. I think so all of you have completed this first table and gave the entry for second, third and fourth arc. Now moving to the next table, which is arc topology table. Okay. In arc topology table, the first column is arc, which is A1, A2, A3, A4. The next two column is start node and end node. Okay. Now the entry in this arc topology table will be given according to the start and end xy, which is given in this arc coordinate data table. If you have taken 4,5 as the start, then n1 will be the start and n2 will be the end. If you have done the reverse 4,3 and 4,5, in that case n2 will be start and n1 will be the end. Okay. So suppose I have taken this one, start is n1, end is n2, and we are moving in this direction. Okay. So if you are moving from n1 to n2, which polygon will fall on the right hand side? If you see on the screen right now, A is coming on the left to you. Okay, but it will on the left if you are navigating from N2 to N1. But if you are written from N1 to N2, you will be moving in the different direction. Therefore, A will come on the right hand side, and on the left hand side, there is nothing in the outside area. Okay, therefore, left is blank. Is it clear? You have to fill rest of the entries in the same way. Start node, end node, left polygon and the right polygon. After the arc topology table, the next one is the node topology table. This table is very simple. You just need to write down the node. There are two nodes, N1 and N2, and how many arcs are passing from this one. From the N1, you can see all the four arcs are passing from N1 as well as from the N2. So in the arcs, you just need to write down the name A1, A2, A4, A3. For N2 also, it will be A1, A2, A3, A4. Okay. For the polygon topology, the fourth table, if you see the first, there are four polygons, three polygons, A, B, and C. In the polygon topology, you need to write down the arcs that are creating these polygons. If you take A, this A polygon is created by arc A1 and A2. Okay. Similarly, you have to enter for B and C. So this one is the final answer. See whether you are getting this answer or not. Is there any confusion in this solution?
Ma'am, just 1 minute. Ma'am, in topology, why you have given a different sequence in writing arcs?
No, you can give any sequence. There is no problem in that one.
Okay. Ma'am, like in E3, in our coordinate data, we have started from N1. Can we start from N2 also? Means we can take either of nodes in starting point.
Yes, you can see that the same thing in A4. Instead of N1 to N2, it is N2 from N1. You have to check whether the graph is directed or not, means whether there is any arrow in the graph or not. If it is non-directed graph, like in this particular example, there is no arrow, you can take any node as the start node and any node as the end node. But if it is a directed graph, in that case, it will be fixed that this one is the start node, this one is the end node. So right now in this such type of undirected graph, you can take anyone as the start node and anyone as the end node. Any other question on the topological data model? In the examination, such type of graph will be given to you, just like the spaghetti data model I have told you. In this one also you will get one such graph, and after that you have to create these 4 tables. If in the question it is given that in the adjacent figure there is a vector data, you need to draw the topological data model for this figure. In that case, you will draw these 4 tables and give the entry in the same way. Common mistake is there in the arc topology table. There is no problem with the node topology and polygon topology, and arc coordinate data also there is no problem. The usual mistake is in the arc topology because students do not pay attention what they are writing in the start node and what is they are writing in the end node. This data must match with the arc coordinate table data. Okay, you cannot suppose that is 4,5 and 4,3 for A1 in this table, and here if you write N2 start node as the N2 and N1 as the end node, in that case it will be incorrect. So this one will be considered as the mistake over here. Make sure that you are making arc topology according to the arc coordinate data, and whatever you are putting in the start and end node, according to that the left and right polygon will get decided. This one is the another place of mistake. Means the student used to get confused what is on the left hand side, what is on the right hand side. In this very example also, there is a question, why are you putting A on the right hand side, although it is coming on the left hand side on the screen? So the answer is you need to check what is the direction you are moving. You are moving from N1 to N2. Therefore, you have to rotate your copy and then you will find what is on the left and what is on the right. So make sure to make this arc topology table correctly. So as there is no other question on this data model, I am moving to the next topic. The next topic is of the database. Okay, why we are learning about this database topic? Because when we talk about the spatial data, or when we talk about the GIS data, every data, every entity, whether it is point, line, polygon, every entity has two components. What are those two components? Where question, where is that entity located? This where component is handled by the spatial data. We have already done the discussion of spatial data in this session also, when we have discussed about the point, line and polygon. Okay, so the where question is handled by the spatial data. The what question is answered by the attribute data. Okay, what is present over here? What is the importance of this place? All this information is handled by the attribute portion. So whatever data you are using, there will be two component, spatial component, attribute component. Okay. Yes. Since after so many repetition, there is a confusion among the student. Therefore, I'm just writing it down so that there is no more confusion at your end, and at least you people would be able to answer what is the spatial data and what is the non-spatial data. Okay. You can say spatial component and in spatial component it will have whatever I am typing on the screen, you need to write down inside your copy. Okay. Otherwise, there is no need. Everything is already written in the lecture notes. I do not need to write it down, but I am writing it down so that you people write all these things in your notebook. Okay. So when we talk about the GIS data, remember this thing, there will be two component, spatial component, attribute component. Spatial component will give you location, the where part, which we have already covered in raster data, vector data, their storage model, their compression things and other. All these things have been covered by now. We are moving to the attribute component. We have already covered this thing previously, in which you have in which I have taught you about what is attribute, what are the different types of attribute. If you remember, there are 4 types. What are the name of those one? Write down in your copy. No need to answer over here. Just write it down in your copy so that you will know how much you remember by now. Quickly write it down. The 4 types of attribute that you have learned. Answer is nominal, ordinal, interval, and ratio. These were the 4 types of attribute data that we have learned. Okay. This attribute will give you the what information, the characteristic information of the data. Okay. How this attribute is created? It is created with the help of database. Okay, so that's why we are learning this topic of database over here. So first we will take some of the example, what is database, why there is a need of database and other things. Okay, like first of all about data. Okay, how much data is get generated day-to-day basis. Okay. So if I take a simple example, suppose you go for a shopping, okay, instead of some local market, we are going to some mall or other place. Now in that place, if you purchase something, okay, suppose I say I purchase some coffee over there. Okay. Now I make the payment of that item of coffee through my card, okay, through my ATM card. See how much data will get generated in this simple process of buying. First, I am paying through my card, so the information will get updated in the bank. In my account, this much money will get debited from my account. Next, I am making a purchase, so there will be update in the inventory of that store, because if you go to these places, everything is in the computer format. You will see that they will not give you the amount. First, they will read the barcode of that item and then you will pay that thing. So when they are reading that barcode, they are updating the database of their inventory. Next, usually in such type of shops, they have a card, customer loyalty card or whatever name they will give. This one is a green card, this one is 4-star card or something like that. Basically, they are storing the purchasing habit of the customer. Okay, so whatever is your purchasing habit, whatever is your shopping pattern, everything gets stored inside that card. Although we people used to get very happy, you know, I'm getting 5% discount because of this card and I'm getting 7% discount from this card, and we are giving nothing to them. The answer is we are giving a very important data to them. We are informing them about our spending habit. We used to give the location, because whenever you fill the form of that card, you used to give your address, your pin code. Okay, you are giving your mobile number, so they are giving you a unique name through your mobile number. They are taking your geographic location based on the pin code. With the help of your shopping habit, they can identify the spending habit of a particular geographic location. Later on in the application, we will learn about these things, but this is what we are giving. We are giving a very precious data to these companies. So this is not our topic. We are coming back to that one. So the third place where this whole buying and selling is stored is inside our customer card. Now, suppose if we are purchasing something that has guarantee or warranty, there will be an update in the company database also. So there are so many data, even a small simple purchasing will generate a lot of data, a lot of changes in the database. Okay. In our day-to-day life, there are several times that we need a support of a database. Like suppose say I am some architect and I want to build some building. So before going to the actual building the building, making that building, first of all, the people used to search in the database. They will search the images of different buildings, different cities, and on the basis of that, they will prepare all these things. Daily, there is a lot of databases that are created, and we ourselves unknowingly access those databases. Okay. Coming back to the GIS part, in GIS also, the spatial data, the location data is linked with the database. You have already created the attribute table in the laboratory session. So when you are creating the attribute table, what you are doing, you are basically creating a database and you are linking the spatial, suppose there is some point, you are locating the information with that point. Like NYC census block example was taken over there. So with each and every census block, the location, the X and Y coordinate of that polygon will be the spatial data. And with that one, we are associating the whole population information, total population, white population, black population, number of houses, rented houses, owned houses. All these are prepared in a separate database, and that database is linked with that particular spatial entity with the help of a common ID. If you remember, and if you see any of the database, you will find that there is a common ID over there. I will show you that thing. Okay, just wait for a minute. There is a little bit lag in the screen, but you will find it out that with every polygon there is an FID. In ArcGIS there is FID, in QGIS there is simple ID over there. FID stands for feature ID. So for every shape there is an ID, and you can see this table. So this is what we are saying, that this one is a database that we are preparing over here. We are associating each of the spatial entity with the particular row on this table. Okay, so this is what we are doing. We are creating a database over here. In GIS, if you see the early development of GIS, there is a concept of AM and FM. What is this AM and FM? There's a thing called AM oblique FM. See the full form of this term, AM, FM. Quickly go to the internet and find the full form of AM and FM.
Automated mapping and facilities management.
Management, yes. Remember, it is management in the last, okay? Automated mapping and facility management, AM/FM. AM/FM, you can see it is one of the very initial use of GIS, although we do not study AM and FM and CAD in GIS nowadays. But if you see the early details or early literature of GIS, it will involve AM/FM. I will write it down the full form. Automated It's automated mapping and facility management. CAD stands for computer aided design. So in the early applications of GIS, you will find that the industry, the utility industries, like suppose there is some power industry or power distribution industry or gas distribution agency. If you remember the definition of GIS that we have discussed, one of the definition of the GIS says that it is an automated inventory of geographically distributed feature. I hope everyone remember that definition of GIS that we have studied, that GIS is the, just wait for a minute, I will open that one. So it says a mechanized inventory of geographically distributed features and facilities for the utility managers, transportation officials, and resource managers. We have learned this definition in the very starting classes of GIS, and here we are coming back to that thing. So AM and FM involves automated mapping and facility management. These are used by the utility companies in order to store their data. Okay, so if there is any gas distribution company, they will need the information of their pipelines, where their pipelines are, where their outlet are, where there is a valve, and all such information. Similarly, for any power distribution company, the information of electric power lines, the transformers, and all the information, whatever they need, This is what GIS for them in the past. So that's why the database, why we are learning AM and FM over here, because we are discussing about the database. For all these AM and FM, the database creation is a very important thing. And with the help of GIS, they have created the detail of their facilities over here. Okay, so in the next turn, because time is already over, it's 1 o'clock. In the next turn, we will start with the database. We quickly cover the database about this relational database and other things. You can go to the Ian Haywood book. Okay, so and just wait for a minute. The chapter number 4 of the Ian Haywood, because this one is a little bit new concept for some of the students because it is a computer science concept. So all of you, before coming to the next lecture of Friday session, read this chapter. Okay, so all the things that were discussed related to database will be clear to you. Read this chapter and I will discuss the detail of database management in the next one. And along with that, I will start the data input part. Okay, and since on Friday there is a tutorial session, so there will be in the coming Friday session, the tutorial will be given to you. You have to write down the tutorial and submit it within a given time. So make sure all of you attend the class on Friday so that you will submit the tutorial. Okay, so thank you so much. That's it from my side. The class is over for now.
Ma'am.
Yes.
Ma'am,
Yes.
ma'am, to travel to that location, I need a one day extra time, maybe Friday.
Sorry, Bhagat, I'm not getting what you are saying.
To travel to campus on Saturday to attend, I need one additional day. I may not able to attend the class on Friday.
The tutorial session is on Friday, so I cannot do anything about that one.
Ma'am, the submission